Hey, good afternoon class. So this is the discussion video for the second part of your carbohydrates. So the topic will start at mutarotation. Okay, so when you say mutarotation, this is the result of the opening and the closing of your sugar molecule rings. Okay, so the hemiacetals and the acetal. So in aqueous solution kasi, your sugar in the ring formation or in the cyclic formation opens and then reverts back to the closed ring. So the result of this is the formation of your mutarotation. Okay, so the straight open Okay, so the straight open chain of D-glucose is so reactive in which all molecules will quickly rearrange their bonds to form two new cyclic structures. Okay, so the open chain, when you say open chain, this one, so open chain yung tuloy-tuloy na carbon chain. Okay, so carbon 1 to 6. So they are open because there are no bonding that is happening between your carbon number 1 and the hydroxide group of your carbon number 5. Okay, so open sila, and your open chains of the carbohydrates or the open forms of your carbohydrates are very reactive forms. Okay, so from time to time, they will rearrange and form new cyclic structures. So when you say cyclic structures, so these are the examples for that. No? So you have either hexose or a pentose. So kapag hexose, 6 na, or 5, 6 na, you have 6 carbon atoms in the, or 6 carbon found in the carbonic chain, and then it will form a pyranose. Okay, so pyranose, 5 ang nasa loob ng cyclic form. Okay, 1, 2, 3, 4, 5, and then ang pang-anim na carbon atom will be at the top. Okay, so yan yung example natin ng cyclic form. Okay, so the two forms differ in rotation of the plane or of the polarized light, which are diastereomers. So meaning they are the two forms that are formed from the rearrangement of your D-glucose, of the open chain D-glucose, will form two isomers. So you have two diastereomers. Okay, so diastereomers, they are mirror images, or they are stereoisomers that are not mirror images of each other. Okay, so they both rotate the plane polarized light. So the one form known as alpha D-glucopyranose. Okay, so alpha, when you say alpha, meaning the hydroxide group is found on the right side. So ito. Okay? Or when you say alpha, since nasa right side yung kanyang, since the hydroxide group is of the carbon number 5 is found on the right side, then always remember that all hydroxyl groups that are found on the right side of a open carbon chain will be written in the cyclic form sa baba, below. Okay, below the ring. Okay, so kapag alpha, yung hydroxyl group will be on the below. So ito siya, nasira ata yung form nyo, no? So dapat meron ditong, well, there must be a hydroxyl group here. Okay, so ito siya beta because the hydroxyl group is found on the top. Okay, nasa taas yung hydroxyl group. Okay, so kapag nasa taas ng ring ang hydroxyl group, you classify that cyclic form as beta. Okay, let's go back. Okay, so the two forms differ in the rotation of the plane polarized light. So one form known as alpha-D-glucopyranose. Okay, so glucopyranose meaning it is a glucose sugar in the form of pyran. Okay, so you have the pyran structure. When you say pyran, it is a ring composed of a 5-member ring. Okay, so 5 na carbons ang nasa loob ng ring. So pyran. Kaya glucopyranose. Okay, so the 6th carbon is located at the or above the ring. Okay, so one form alpha-D-glucopyranose has the specific rotation. Okay, so specific rotation, you have positive 112 degrees. So when you say positive, meaning ang rotation niya is to the right side or clockwise. The other form naman of your D-glucose is the beta-glucopyranose. When has a specific rotation of 18 or positive 18.7 degree. Okay, so pareho sila ng direction actually ng rotation ng plane polarized light. So positive din siya, so meaning sa right side pa din or clockwise, but the degree is much smaller. So when these two forms of glucose are placed in separate solutions, okay, so kapag yung alpha-D-glucopyranose and beta-D-glucopyranose, ilagay mo siya sa magkakaibang rotation, sa magkakaibang solutions, and wait for it or allow it to stay there for several hours, then later on, if you check again the specific rotation, both of them will have a specific rotation of 52.7 degrees. Okay, so 57 or 52.7 degrees. So pareho na sila kanina nung hiwalay pa 120 and 18.7. But if you place them on a solution, different solutions, naging pareho yung kanilang specific rotation. So this phenomenon is called your mutarotation. So to explain this, your glucose exists in a solution as an equilibrium mixture of two cyclic forms and open chain. Okay, so tingnan natin dito. Sabi niya, when you place or when the D-glucose is in a solution, it exists in 3 types of form. So the two forms are the cyclic form. So you have the alpha and the beta. And the third form is the open chain form. So yung tatlo na yan, they actually exist in a solution containing your D-glucose. Okay. So the two cyclic structures are optical isomers, meaning they rotate the plane polarized light, which differ only in the orientation of the hydrogen and the hydroxyl or hydroxide groups in carbon number 1. Okay, so saan sila magkaiba? Sa carbon number 1. So, ang alpha mo nga, you have the hydroxyl group for the alpha on the below the ring, and for the beta, you have the hydroxide or the hydroxyl group above the ring. Okay, so carbon number 1. So, when dissolved, some of the alpha-glucopyranose molecules are converted into beta-D-glucopyranose and vice versa until an equilibrium is reached between alpha and B form. So, kapag when you place your alpha and your beta-D-glucopyranose in a solution or an aqueous solution, they actually are converted to the opposite form. Okay, so the alpha and the beta will be converted vice versa until ma-reach nila yung equilibrium solution. So ano ba yung equilibrium solution for your D-glucose? You have 36% alpha molecules, 64% beta molecules with a trace of open chain molecule. Okay, so 36% doon is alpha, 64% doon is beta. And then, meron kaunting open chain molecule, this one. Okay, so the more stable molecule has the higher percentage. The more stable the molecule has the higher percentage. Okay, so yung mas mataas na percentage between the two, yun, that means it is the more stable form. So dito, ang more stable form is your beta molecule because it is 64%. Okay, so in this solution, yun nga, beta molecules are more stable. So when two cyclic isomers differ only in their stereo arrangement about the carbon involved in mutarotation, they are called anomers. So ang tawag mo dito sa dalawa, your alpha and beta D-glucopyranose, they are both anomers because same sila, they are cyclic structures or cyclic forms of your glucose that are the same with their structure but differs only in the arrangement of hydrogen and the hydroxyl group on the carbon number 1. Okay, so always anomers will always differ in only one carbon atom in the ring. Okay, so mutarotation is this means that alpha and beta D-glucopyranose are anomers. Okay, so they are anomers. Mutarotation is the process in which your anomers are interconverted. Sabi nga natin kanina, when you place alpha and beta glucopyranose in or a D-glucose in a solution, yung alpha and beta will be interconverted, no, vice versa, until they reach an equilibrium in the solution. So, yung interconversion of your anomers is the one that is making the phenomenon mutarotation possible. Okay, so how is that? Because when you place, kapag naglagay ka nga ng sugar or when you place D-glucose in a liquid solution or sa isang aqueous solution, nagkakaroon ng there is opening and closing of your ring cyclic forms or your ring or your cyclic forms. So mag-open and mag-close sila until they will reach the equilibrium of for the solution. So when that happens, mutarotation is the phenomenon behind that. Okay. So dito, as you can see, so ito tayo. Okay, so the Haworth projection formulas are used in cyclic structure. So yung itong formula na yan, that is what you call the Haworth projection formula. So ito this is the formula of Fisher projection formula. Ito, yung straight chain. The straight chain, ito siya. While the ring structures is what you call Haworth projection formula. So it represents the molecules as a flat hexagon with hydrogen and hydroxide groups above and below the plane of the hexagon. So flat hexagon with hydrogen and hydroxide either at the top or at the bottom or below the ring structure. So in an alpha form, the hydroxyl on the carbon number 1 is written below the plane. And in beta, the hydroxyl on carbon number 1 is written above the plane. So pag beta, the hydroxide is on the top of the plane. If alpha, the beta, or the one in alpha, the hydroxyl group should be on the, okay, yan, okay, yan siya, yan. So when for the alpha, the hydroxyl group is found below the ring. So yan yung pinakaiba nila. So ang when you say anomers, they are isomers that differ, or they are cyclic forms that differ only in one in the arrangement of a single carbon atom, which is the carbon number 1. Okay, so in converting Fisher projection formula to Haworth formula, the hydroxide groups is written below the plane if they project to the right and above the plane if they project to the left. Okay, so the last carbon, for example, carbon number 6 is written above the plane. Okay, so tingnan natin dito. This is your Fisher projection formula. So, ayusin natin. Ayan. Ayun naman pala. Okay, so this is your Fisher projection formula. So, the ones that are projected on the left side of the Fisher projection formula will be placed on the upper or above the hexagon ring. Okay, so lahat ng nasa left, sa taas mo ilalagay. For example, dito, you have for carbon number 2, so ito yung carbon number 1 natin. Okay, so for carbon number 2, you have H, hydroxide, HH. So, nasan sila? Since nasa left side, so nasa taas sila. So, you have H for carbon number 2, hydroxide group for your carbon number 3, and then another H for your carbon number 4. So, nasa taas siya. Okay, so for your carbon number 5, okay, so nasa taas ng carbon number 5 yung carbon number 6 because your carbon number 6 is projected to the right. So, lahat ng projection lahat ng hydrogen and hydroxide groups that are projected on the right side will be placed below. Okay, so sa ilalim siya. So for example, carbon number 2, so sa baba ang hydroxide, carbon number 3, nasa baba ang H, carbon number 4, nasa baba pa rin ang H. Okay, and then you have your carbon number 5. Okay, so yung carbon number 5 natin, always, kasi sa kanya din nakadikit yung, so wala na siyang hydroxide group. Okay, tandaan. So, looking at your alpha and your beta. At carbon number 5, always na H yung nasa baba. Okay, so hindi nakasali yung carbon number 5 because its hydroxide group is the one that bonded with your carbon, with the oxygen found in carbon number 1. So, kita nyo ito, carbon number 1, the oxygen of it bonded with the hydroxide group of your carbon number 5. So, dito, ang natira na lang is ang H, ang hydrogen, and ang CH2OH. So, since sa right, ang iyong CH2OH, siya ang nasa top. And nasa baba yung H. So, wala na kasi siyang ibang position na pwedeng puntahan yung H. So, ang always lang tingnan para doon sa projection ng hydrogen and hydroxide is yung carbon number 2, 3, and 4. Your carbon number 5 is an exception because its hydroxide group already bonded with the oxygen group of your carbon number 1. So, yung formation ng carbon number 5, always na siyang constant. So, hindi na yan nagbabago. Either alpha or beta man yung structure, the position of the functional groups that are bonded to your carbon number 5 will not change. Okay? So, always nasa baba ang hydrogen niya and always nasa taas ang CH2OH. Ang magbabago lang kapag in-convert mo ang Fisher projection formula into a Haworth projection formula are the carbons 2, 3, and 4. Okay? Yung hydrogen and hydroxide group nila will depend kung saan ilalagay, will depend if nasa left or nasa right side sila. Okay? For your carbon number 1 naman, hindi mo na tingnan kung nasa left or nasa right siya because always kapag when you are converting the Fisher projection formula for a certain sugar, always present ang alpha and ang beta form. Okay? So, may isa kang alpha, may isa ka talagang beta. So, para makuha ang alpha, so, you will place the hydroxide group sa baba for alpha, and then for the beta naman, beta structure, you will place the hydroxide group at the top. Okay, so that is how you write. So mamaya meron tayo ditong sample kung paano mag-start or how you will write the structures or how you will be converting projection, Fisher projection to Haworth. Okay, so the explanation of the cyclic formation of aldohexoses like D-glucose is this. Looking at the open chain from D-glucose, carbon number 1 reacts with your hydroxide group in carbon number 5. So, tapos ko na na-explain. To form an intramolecular hemiacetal or a 6-membered ring, which you call pyranose because of its similarity to pyran. Okay. So, kapag ang hexose, hexose composed of 6 carbons, will be converted into a Haworth or a ring form, okay, you will be producing a hemiacetal. So, when you say hemiacetal, this is, your hemiacetal is forming a pyranose. Okay, so ang hemiacetal is composed of an ether linkage. Okay, so merong ether linkage. Okay, so the structure of your hemiacetal has either an ether linkage and an alcohol linkage on the same carbon. So, ano ba yung structure ng, what is the structure of your acetal or the hemiacetal or the ether and the alcohol linkage? So, your ether is ROR. Okay, ROR or it is, so wait lang, I will give you an example. Okay, so this is the example of the structure of your ether group. Okay, so when you say ether group, this is composed of ROR structure. So the R here are, yung R ninyo dyan, yan yung carbon group. Okay, so when you say carbon group like this, so a carbon group or an alkyl group is composed of a carbon chain. Okay, so any group na merong or any molecule na merong carbon, for example, CH3, CH2OH, so yan, lahat ng may carbon R. So meaning, one carbon connected to another, connected to an oxygen, and the oxygen is connected to another carbon. So, carbon, oxygen, carbon. Yan yung structure ng the structure of your ether group. While yung alcohol group naman, same lang dito, pero ang pinagkaiba, so dito merong OH. Okay, so R, you have R connected to an oxygen and then connected to a hydroxyl group. Merong OH. Okay, so yan yung composition ng inyong hemiacetals. Merong ether and alcohol group. Okay, so sabi niya dito, the structure of the hemiacetal structure has ether linkage and alcohol linkage on the same carbon. Listen natin yan. So meaning, merong magkadikit na ether group and alcohol group doon sa inyong hemiacetal. So, nasaan siya? Okay, so one example is this. Asan ang hemiacetal group? This one, the COC. Diba? Tama? ROR. Carbon group connected to an oxygen group connected to another carbon group. You have the ether. ROR. And then, sabi doon, hemiacetal group contain ether linkage and alcohol linkage in the same carbon. So, meaning, sa carbon 1, there is an OH na nakadikit. So, ROR nakadikit sa structure din ng alcohol na or ROOH. Okay, ROH. You have your R and or the carbon group plus your OH. So, ROR and then ROH. Nakakonect ang ether group sa alcohol group in carbon number 1. So, meaning your alpha-D-glucopyranose is a hemiacetal kasi meron siyang presence ng both ether group and COH or ROH or alcohol group on the same carbon, on carbon number 1. Okay. Similarly, the carbon number 2 in the open chain form of a ketohexose such as D-fructose can form an intermolecular hemiketal by reacting with either a hydroxide group in carbon number 6 to form a 6-membered cyclic hemiketal or a hydroxyl group in carbon number 5 to form a 5-membered cyclic hemiketal. So, kanina, the aldose, okay, so sa aldoses, ang tawag sa kanila is hemiacetal. Kapag sa ketoses tayo, ang tawag is hemiketal. Okay, so, what are the structures of your what are the structure of your ketose? Okay, so sabi natin ang ketose, it contains we said that your ketose contain the CO or the carbon double banded oxygen, this one on the carbon number 2, diba? So, ang aldose kasi natin, ang kanyang CHO or C double band O and H are found on the carbon number 1, tulad dito, diba? So, this is an aldehyde or an aldose because nasa carbon number 1 yung aldehyde group. While on your ketone, the carbonyl group is found on the second, nasa second carbon siya. Tumaayos. Okay, so example dito. Okay, diba? So, ang carbon number 1 niya containing CH2OH, hindi CHO. Nasa carbon number 2 yung double band oxygen. So, this is a ketose. So, one example of a ketose sugar is your D-fructose. So, when you form or in order for a ketose to form a ring structure or a cyclic structure, so kailangan the carbon number 5, so pwedeng dalawa, no? Pwede siyang mag-form ng actually ng tatlo din ng pyran structure. So, itong carbon number 6 ang the hydroxide group of the carbon number 6 will bond with the oxygen of the carbon number 2. Pero dito, ang example natin is, or the structure for your D-fructose is actually a furanose. Okay, furanose siya coming from the structure of furan. So, para siyang pentagon ang shape niya. Okay? So, hindi siya hexagon, pentagon. Kasi, when you say furan, it is a 5-membered ring structure. Unlike kanina, yung pyranose, 6-membered ring structure siya. Your furanose or your furan, only 5-membered structure. Okay, so, ang carbon number 1 niya, okay, so dapat ito nandito yan siya. Copy. Paste. Ay, naku, ayaw niya. Iyon natin ito. Ayun. Okay. So, 5-membered ring siya. So, you have, ang carbon number 1 niya, ito, CH2OH, nasa taas. Magsa-start ang cyclic form sa carbon number 2 kasi nandoon yung carbonyl group. Okay, nandoon yung oxygen. So, yung oxygen, double bond oxygen mo will bond with the hydroxide group of your carbon number 5. Okay, so forming a furan structure. Okay, so carbon number 2, see this? Nag-connect siya sa hydroxyl group of the carbon number 5. Okay, so ang tawag dito is hemiketal. Hemiketal siya. Okay, so the 5-membered ring is called furanose because of its similarity to furan. So there are 2 cyclic forms of your D-fructose as a result of the cyclization as shown in figure 5. So ito siya. So when you say cyclization, this is the conversion of your open chain to a ring structure. Again, yung cyclization, the conversion of an open chain form to a ring or cyclic form. Okay, so the hydrogen atom will be bonded to carbon number 2 oxygen atom to form hydroxyl or hydroxide group. So the more stable structure is alpha D fructofuranose because the OH group in carbon number 2 and 3 are far from each other. That means less interaction compared to beta D fructofuranose. So sabi niya, mas your alpha D fructofuranose is more stable compared to your beta D fructofuranose. Why? Because when you look at carbon number 2 and carbon number 3, nasa magkabilang sides ang OH group nila. So for carbon number 3, nasa taas ng ring structure, while for carbon number 2, nasa baba. Unlike your beta furanose na both of the both of the hydroxide groups are found na on the upper side of the ring. So magkatabi sila. So mas stable ang isang cyclic structure if magkakahiwalay yung hydroxide groups. Because they will become stable. When you say stable, less interaction, so lesser din yung reaction nila with other molecules and with the inside of the structure mismo. Okay, so hindi magkakaroon ng interaction with the hydroxyl groups in the alpha D fructofuranose kasi nasa magkabilang side yung hydroxide group nila or nasa magkabilang side ng ring ang kanilang hydroxide group. Okay. So, mutarotation results from the opening and closing of your ring structures. Okay, so Haworth formulas are also shown in abbreviated schematic structure like this. So, ito siya, para mas mabilis isulat, mayroong abbreviated form or abbreviated structure yung Haworth formula. So, dito, hindi mo na isusulat isa-isa yung C, yung OH and H, ganyan. Mabilisan na lang to. So, you will first write, tulad dito sa symbol, you have alpha D positive glucopyranose and beta D positive glucopyranose. So, anong meaning ng mga names na yan? Alpha, because the OH group is found below the ring structure. D, meaning yung carbon number 5 niya, it contains the hydroxyl group on the right side. And then positive, meaning this structure or this form rotates the plane polarized light to the right or clockwise. And then glucopyranose, meaning this is a glucose in a pyranose form or in a pyran form or a 6-membered cyclic form or ring. Beta naman, you have beta D positive glucopyranose, beta for the OH. So, yung OH, since beta siya, nasa taas ng ring yung hydroxyl group. D, so same with this, positive, same din, positive, pareho sila ng direction ng rotation of the polarized light, and glucopyranose. So, same lang. So, saan lang sila nagkaiba? Sa alpha and beta. Okay? So, the 5 open bonds, eto, when you say open bonds, this one. So, wala siyang H, diba? Walang H, walang H, walang H, walang H. So, this is under direction, ano. So, this means na meron ng hydrogen dyan. Hindi mo na kailangan sulatan ng hydrogen because it is understood already to have a hydrogen, or represents the hydrogen atom on all the open bonds. So, yan. And all the 5 intersections represent your carbon atom. So, lahat ng matutulis or lahat ng intersection ng hexagon or lahat ng sides ng hexagon will represent the presence of your carbon atom. So, 1 carbon atom, 2, 3, 4, 5, and 6 carbon atoms. So, all the Fisher and Howard projection formulas for cyclic structures only approximate to the true molecular shape. So, meaning ito siya, approximation lang ito ng molecules, kung ano yung shape nila. But, we use this for easy drawing of the structures para lang masulat natin yung structures in paper. But your pyranose ring is not flat, okay? So, hindi talaga ito siya flat sa totoong buhay, okay? So, yung molecules are not hexagonic, or they are not hexagon and flat structures talaga. But can assume a chair or a boat conformation like the cycloalkanes for stable structure. So, ang totoong shape nila is when you look under a microscope, no? So, sa laboratory, ang shape talaga nila is a chair or a boat. So, yung chair and boat na structure or conformation, yan yung most stable structure, no, for your molecules. Okay, so most naturally occurring monosaccharides are found in the chair form. So, lahat nung yung monosaccharides ninyo coming from organic sources are found in a chair form. So, even in the chair form, the two cyclic structures, D-glucose, differ only in the relative positions of hydrogen and hydroxide groups attached to number 1. So, kahit na yung doon sa true form nila or sa true structure nila, which is the chair or the boat form, nagkakaiba lang talaga sila sa arrangement ng hydrogen and hydroxide group on the carbon number 1. So, this minor difference has significant biochemical consequences because the physical shape of the molecule often determines its biological use. So, yung physical shape ng molecules, yan ang nagdedetermine ng kanilang function. Okay? So, the structure is very important. For example, the structural difference between your starch and cellulose. So, actually, your starch and cellulose has the same structure. Magkaiba lang sila sa carbon number 1 arrangement because your starch is a polymer of, when you say polymer, so aggregation or group monomers, okay, or it is a product of the formation of your alpha-D-glucopyranose. So, meaning, yung monomers ng inyong starch are alpha-D-glucopyranose. So, alpha, meaning, ang hydroxide group niya on carbon number 1 is found on the or below the ring. While your cellulose is a polymer for your beta-D-glucopyranose. Okay? So, ang monomers ng polymer is the beta-D-glucopyranose and their hydroxide group is found above the ring. So, as a result, kita nyo, very specific yung biological processes. So, ang nadadigest lang ng humans is yung starch lang or the form of glucopyranose that a human can digest is yung alpha form lang. Okay? So, yung cellulose, it cannot be digested by the human body. Okay? So, cellulose. So, mag-aiba lang sila on being alpha or beta. But the effect on the human body is very humongous. Okay, for example, you write the Pyranos-Haworth formula and names for the two anomers of the mannose. So when you say anomers, again? Anomers are what? The same structure of cyclic forms but differs only in the arrangement of one carbon atom. Okay. So, di-mannose daw. So, first, anong unang gawin? Write the open chain for the di-mannose. Okay, so always magsimula sa open chain. So, I guess you've already familiarized the structures of the 16 hexoses, okay, or aldohexoses. Sana na-familiarize na yan. You have the allose, the mannose, yun. So, 16 sila because you have the 8 D forms and the 8 din na L form. Okay? Okay, so, solution. So, write mo ng open chain ng di-mannose. Number the carbons. Okay, so, from the top. Okay, so, top, yung carbon number 1 mo, tandaan, ang carbon number 1 is always the carbon containing your aldehyde or your ketose group. Diba? So, yung ketone group or aldehyde group, kung saan sila makikita. So, for ketose, you will see ketose on carbon number 2. So, meaning kung saan nakadikit yung ketose group C, double bond O, yun ang carbon number 2. And kung saan naman nakadikit yung aldehyde group, which is CHO, then meaning yun ang carbon number 1. So, from top to bottom. So, ang pinaka-bottom mo is yung carbon number 6 or the primary alcohol group. Bakit siya alcohol group? It contains meron siyang attachment of an alkane and a hydroxide group or CH2 and OH. So, primary alcohol group siya. So, nasa huli siya always. So, after mo na-draw ang structure ng di-mannose with the numbers of carbons, draw the structure of the Haworth-Pyranose ring or the hexagon. Okay, so tandaan. Always hexagon ang ginagamit for your hexose sugar. Okay, so baka ma'am, paano if ang ginamit ko furan? Hindi pwede. Okay, so para sa hexose sugars, always pyranose or your hexagon shape. Ang ating furanose, para lang yan siya sa ketoses. Kuha. So, para lang sa ketoses ang structure ng furanose. So, katulad na ng example kanina, you have the fructose. So, yung furanose, ang shape niya is pentagon. So, 5 sides lang. Okay. Draw the structure of the Haworth-Pyranose ring hexagon. Place the numbers of the carbon in the ring from carbon number 1, okay, below the oxygen, dito, moving clockwise until carbon number 6. So, diba una, you've written the structure of the hexagon. So, saan always isusulat ang carbon number 1? Dito sa side, sa baba ng oxygen. So, dito ka always mag-start ng number 1. And then, clockwise, so meaning to the right. So, 1, 2, 3, 4, 5, 6. Okay? And you will find your oxygen on a constant position. So, always nasa taas na left side ang oxygen. So, this is a constant form for your pyranose. Magkakaroon lang ng kaibahan sa pag-draw mo or sa paglagay mo ng arrangement of the hydrogen and hydroxyl atoms or hydroxyl group to the either kung left side ba siya or right side. So, dito lahat ng left side isusulat sa taas. So, you have for carbon number 2, nasa taas dapat ang hydroxide. And then carbon number 3, ganun din. And then for 4 and 5, nasa baba. So, kita. So, 2 and 3, nasa taas. And then, okay, so yung 5 pala, hindi na siya kasali, no? Kasi yung hydroxide group niya, it already connected with your oxygen. So, always tandaan, 2, 3, and 4 lang tayo. So, 2, 3, and 4. Your 4 found below yung hydroxyl group. Okay, so the carbon involved in neutral rotation is carbon number 1. So, meaning, hindi mo siya muna lalagyan ng hydroxide group. Because it means na dalawa kasi yung ginawa mong structure. So, ang carbon number 1 yung involved sa neutral rotation kasi siya ang may hawak ng double bond oxygen, and that oxygen bonded with the hydroxide group of carbon number 5. So that means there are 2 positions for your carbon number 1, the alpha and the beta. So alpha anomer saan? Ang alpha anomer hydroxide is below the ring, and the beta anomer, the hydroxide is above the ring. Okay, so ito na yung dalawang structure ng iyong mannose or D-mannose. So you have alpha D-mannopyranose and beta D-mannopyranose. Okay, let's go to pentoses. Pentoses. So your pentoses, an open chain aldopentose. So aldopentose meaning aldehyde siya. It is an aldehyde containing 5 carbon atoms. Okay, so has 3 chiral carbons using the formula of stereoisomers 2n. So palitan mo, since 3 ang chiral carbon atoms, 2 to the power of 3 will result to 8. So, meaning, merong 8 stereoisomers there are 8 stereoisomers for the chain aldopentose. So, this means that 4 are D-isomers and then the other 4 are L-isomers. So, always ihati. 4 na D-isomers, 4 din na L-isomers. Okay, so for your D-isomers, you have D-ribose, D-arabinose, D-xylose, and D-lysose. So the other 4 are L-isomers or their mirror images. Okay, so arabinose and xylose found in some plants as polysaccharides are called pentosans. Okay, so yung arabinose daw and your xylose na nakikita sa plants, ang tawag sa kanila, or when they exist as polysaccharides, they are called pentosans. So the most important pentoses are the D-ribose and the D2-deoxyribose. So anong pinagkaiba ng D-ribose and deoxyribose? Again, your D-ribose is the sugar found in your RNA, okay, ribonucleic acid. And your D2-deoxyribose is the one found in your DNA. Okay? So, ang pinagkaiba nila, your ribose, okay, the difference between the two structures is in the carbon number 2. So, in which the oxygen is removed in D2-deoxyribose. So, kaya nga deoxyribose. So, when you say deoxy, meaning deoxygenated. Okay? Deoxygenated. Pinaikli lang yan. So, meaning it is a deoxygenated ribose or a ribose that has been removed, or the oxygen from the ribose has been removed. So, the structure of the two pentoses in open chain form and stable ring structure is shown. Okay, so you have your D-ribose and D2-deoxyribose. Okay, so yung structure ng D-ribose ninyo and deoxyribose, these are constant na, always constant, hindi nagbabago. Okay? So, sabi ko kanina, the structure of the furanose is only for ketoses, right? Okay, so para lang siya sa ketoses. And pwede rin siya sa pentoses. Okay? So tandaan, para siya sa ketoses and sa pentoses. Pentoses, why? Because your pentoses only consists of 5 carbon atoms. Ngayon, if you will convert a pentose sugar or a pentose aldehyde into a pyranose structure, hindi pwede kasi wala 5 lang yung kanyang or 5 lang ang carbon atoms niya. Hindi siya aabot ng 6. So it will not form hexagon. Okay? So isa sa your pentoses will form furanose. Even though na aldehyde sila because they contain CHO sa top or sa carbon number 1, they will form furanose because they contain only 5 carbon on the carbon chain. So, pentagon shape yung kanilang magproproduce. Okay? So, tandaan, the ones that can use hexagon shape or the pyranose structure, ring structure, are the aldehydes that contain 6 carbon chain. Okay, so for your riboses or for your pentoses and your ketoses, you will use furanose. So pwede rin naman doon sa ketoses, actually, you can actually use the hexagon or the pyranose. Pero, most commonly, ang ginagamit for ketoses is yung 5 or your furanose. Okay, so for the 4-membered ring. Okay, so the ketopentose that is closely related to your ribose is your diribulose. Okay, so yung ketopentose daw or a ketone containing 5 carbons that is closely related to your D-ribose is the D-ribulose. So this is a ketose, or this ketose is an intermediate allowing cells to make many monosaccharides. Okay, so yung function ng ketoses is for the reproduction or for the production of many monosaccharides. So, in photosynthetic organisms, your D-ribulose is used to capture carbon dioxide and make new carbohydrates. So, ano yung example ng mga organisms that are photosynthetic? You have your plants. Meaning, your D-ribulose are present in plants, so they are used to capture carbon dioxide. Okay, so the structure is shown as, okay, keto siya, why? Because the carbonyl group or the C double bond O is found on the second carbon. Okay, so this is the structure of your D-ribulose. So can you draw the Haue formula? Okay, so you can actually answer this at home. So pwede as a practice test for you. Okay, the last part of the topics for your prelim are the disaccharides. Okay, so your disaccharides, carbohydrates that are composed of 2 monosaccharide residues or units. So they are united by a glycosidic linkage and are called disaccharides. So when you say disaccharides, they are composed of 2 monosaccharide units. So again, ano yung naglilink doon sa dalawang monosaccharide units? Your glycosidic linkage. Okay, so sucrose and lactose, they both have molecular formula C12H22O11. So, kita nyo kasi combination sila ng dalawang hexoses, correct? Your sucrose and lactose, these are disaccharides. So, combination sila ng dalawang hexoses. So, 6 na carbon, kaya ang formula nila is C12. 6 plus 6. So, C12H22O11. Okay. So, your sucrose and lactose are two important disaccharides found in free state in nature. So, meaning they are organic. Your sucrose and lactose are organic substances. Sucrose exists throughout the plant kingdom and also known as your table sugar. Okay, so yung sugar na hinahalo sa kape or sa mga inumin, so that is actually the sucrose disaccharide. So the sources of your sucrose are sugarcane. Okay, so any of you that have tried eating sugarcane, then so it is 15 to 20% sucrose. Your sugarcane contains 15 to 20% sucrose. Next, sugar beets containing 10 to 17% sucrose, maple syrup, and sorghum. Okay, so lactose is found free in nature, mainly in the milk of mammal. So yung human milk or the breast milk contains about 6.7% lactose, higher than cow milk. Okay, 4.5% lactose lang yung cow milk. So mas mataas yung lactose level ng milk na nanggagaling sa human. Okay, so there are several other important disaccharides derived directly from polysaccharides by hydrolysis. Okay. So maltose, isomaltose, and cellulobiose are formed when specific polysaccharides are hydrolyzed. So again, ano yung hydrolyzation or when you say hydrolyze, these are the breaking of bonds in chemical compounds or in molecules. The breaking of bonds in molecules which occurs in the presence of water and acid or an enzyme. Okay? So, your hydrolyzation or your hydrolysis will always occur in the presence of water, coming from its name. So, water. So, hydrolysis siya because kapag when two bonds or kapag yung bond in you actually form water molecules. Okay, so needed yung presence ng water molecules. So, coming from the word hydrolysis, so hydro or yun, hydro meaning water. So, when the disaccharides, so your maltose, isomaltose, cellulobiose are formed when specific polysaccharides are hydrolyzed. So, the most common of this group is your maltose that is found in the component of the sprouting grain. Okay, maltose, nakikita siya sa grains. So, when the disaccharides are hydrolyzed, two monosaccharide molecules are formed. So, the hydrolysis is catalyzed. So, again, your hydrolysis needs catalysis or the speeding of the rate of a reaction. Okay, so kailangan merong catalyst na present in your hydrolysis. Okay, so pwede siyang na-catalyze with the presence of an elevated temperature, meaning by warming or boiling, and with the presence of hydrogen ions or your acids, or by certain enzymes. So, your enzymes are biological examples of your catalyst. Okay, so enzyme speeds up a chemical reaction. So, they act effectively at room, okay, your enzymes will, okay, so ito yung another side for the enzymes. They will only serve their best, or they will act their best in the presence of a certain temperature. Okay, so for this, kailangan room or body temperature yung present in order to hydrolyze your saccharide. So, a different enzyme is required for the hydrolysis of the three different disaccharides. So, yung disaccharides ninyo, per disaccharide, dapat meron ding specific type of enzyme. Okay, so remember your enzyme always end in ASE. So mali ito. Sucrase dapat yan. Okay? Okay, sucrase dapat yan siya. Okay, so all enzymes ends in ASE. So for your sucrose, with the presence of water and your acid or the enzyme sucrase, it will be hydrolyzed into glucose and fructose. For your lactose, you have the lactase enzyme. It will be hydrolyzed to galactose and glucose. And then you have the maltose. With the presence of maltase enzyme, it will be hydrolyzed to glucose plus glucose. So yung itong sucrase, lactase, and maltase, these are actually found inside the body, no, in the digestive system. Okay, so they are actually digestive enzymes. In order to allow the body to digest your sucrose, lactose, and maltose. So, present ito sila sa human body, yung tatlong enzymes na yan. So, in one example is the small intestine of infants or babies. They have the enzyme lactase that allows them to easily digest lactose from their milk diet. Okay? However, kapag tumatanda yung tao or when the, people mature, their intestines often stop producing the enzyme lactase. So, ang mga adult, usually, napakaliit na ng presence ng lactase enzyme in the body. As a result, merong ibang tao na that lose the ability to digest lactose. So, this sugar is metabolized by common bacteria that live in the large intestine. So, kapag nawala yung lactase, the ones that replaces it for the lactose to be metabolized is yung common bacteria sa large intestines ng human body. So, because of this, the person will experience gas and intestinal discomfort. So, bakit nga? Diba, bacteria, they actually produce gas, okay? And they have discomfort effects on the sa ating tiyan. So, kapag may yung ibang tao that are lactose intolerant, okay, they cannot digest, or yung lactose that they intake, they can't digest or metabolize the lactose. Okay, so ang meron kasi sa stomach nila, so wala na sila masyadong lactase enzyme sa kanilang digestive system. So, bacteria na yung common bacteria na yung nagda-digest if they will intake lactose. Kaya, nagkakaroon ng gas and intestinal discomfort for those people that are lactose intolerant. So, this condition afflicts many adults. Okay? So, to take note that small differences in molecular shape between lactose and the other disaccharides often determine what our bodies do with specific molecules. Okay. So, disaccharides contain an acetal structure or two ether linkages. So, ang pinakaiba ng kanina, 'di ba, sa ating sample kanina, for the D-glucose or your monosaccharide, ang structure nila is hemiacetal, correct? So, your hemiacetal is composed of an ether group and an alcohol group, or ROR and ROH. Now, your disaccharides, they are actually composed of acetal structures. So, when you say acetal structures, two ether linkages. So, meaning, dalawang magkadikit na ROR, ROR. So, wala ng alcohol linkage or ROH. So, yan yung present sa disaccharides, your acetal structures, which is also called the glycosidic linkages. That's why yung glycosidic linkages that bonds monosaccharide units, they are not found in your monosaccharides kasi hindi naman, wala namang bonding doon sa mismong monosaccharide. So, there are just bonding of units between disaccharides, oligosaccharides, and polysaccharides. So, yung glycosidic linkages natin, they will be first seen in your disaccharides. So, you also call them as acetal structure. And some also contain hemiacetal structure. So, merong iba na merong hemiacetal, but usually your hemiacetal structure are found mostly in monosaccharides. So, in maltose, the acetal structure is formed from two glucose molecules through elimination of water molecule between hydroxide and on carbon number 1 of one glucose and the hydroxide group of carbon 4 of the other glucose.